Okay, so you grab your hair straightener, maybe a curling iron.
It feels pretty normal, right?
Part of the morning rush for lots
Oh,
of
yeah.
us.
Exactly. You don't really think twice about it.
But what if that simple action was actually changing the air inside your home in a way you didn't expect?
It's fascinating stuff. There's this surprising new research suggesting that everyday heat styling, using those hot tools, it might be a pretty significant source of indoor air pollution.
Something we just haven't really recognized before.
Right there in your house.
So that's what we're diving into today. We want to unpack the science behind it, look at the actual numbers, like what you might really be exposed to, and talk about why this actually matters for your health.
We've basically taken a stack of research and are boiling it down for you. The key takeaways.
Okay, so let's get into it. What's actually being released? You mentioned pollution, particles.
Right. So when you use heat, especially if you've got products on your hair creams, serums, that kind of thing, the combination releases these airborne nanoparticles.
Nanoparticles. Okay, how small are we talking?
We're talking incredibly tiny, like 6 to 500 nanometers. To give you some scale, a single human hair is maybe 80,000 nanometers thick. So, yeah, very small.
Wow, okay. So what's the science there? How does heat plus hair product equal nanoparticles?
Well, the main thing happening is heat-driven volatilization. Fancy term, but basically...
It means the heat turns stuff into gas.
Exactly. It makes chemicals, especially these things called cyclic siloxanes, found in lots of products, stuff that doesn't easily evaporate normally, turn into a vapor.
Okay.
Then, as those vapors cool down just slightly in the air around the tool, they kind of clump together, they nucleate, and grow into these tiny solid or liquid particles.
Nanoparticles.
Nanoparticles, yeah. There's a bit of a secondary thing, too, with ozone reacting with fragrances, but the heat-driven part seems to be the main driver.
And temperature must play a huge role here.
Oh, absolutely crucial. They did experiments in this special test house at Purdue, and when they styled hair above 300 degrees Fahrenheit, the particle concentrations shot up.
How high are we talking?
Like 10,000 to over 100,000 particles per cubic centimeter of air. Huge numbers.
That's a lot. And you mentioned particle size earlier. Does the heat affect that too?
It does, and this is really eye-opening. Above 360 Fahrenheit, over 95%, almost all of the particles were these ultra-tiny ones, less than 100 nanometers.
And then those are the ones that go deepest into your lungs, right?
Precisely, yeah. They actually estimated the deposition in the respiratory tract. At 410 degrees Fahrenheit, which isn't uncommon for some tools.
Yeah, definitely not.
They calculated something like 65 billion nanoparticles could deposit in your airways during one styling session.
65 billion. Compared to what?
Well, compared to maybe 880 million at 300 degrees, or only about 70 million at room temperature, just from the product itself. So the heat makes a massive, massive difference.
That really puts it into perspective. So this leads to personal exposure. How much are you potentially breathing in?
The modeling suggests, as we said, potentially over 10 billion nanoparticles depositing in your respiratory system in just one session.
And where do they mostly end up?
Surprisingly, the highest dose seems to be in the pulmonary region. So deep in the lungs. And you have to remember, you're doing this right near your face, near your nose and mouth.
Right. So it's concentrated exposure, even if it's for a short time.
Exactly. Elevated short-term exposure.
Are there things that make this worse for some people, like factors that increase your dose?
Yeah, definitely. First off, hair length. Makes sense, right? If you have long hair, you're probably styling for longer.
Takes more time.
Right. And that could mean about a 70% higher dose compared to someone with short hair.
Okay, what else?
Ventilation. Or lack thereof.
The steamy bathroom effect.
Kind of, yeah. Less air exchange means the particles just hang around longer. They found reducing the air exchange rate, basically how quickly the air in the room gets replaced, from 6.5 down to 3.0 changes per hour, upped the dose by 33%.
And most homes probably have even lower air exchange than 3.0, right?
Oh yeah, often below 1.5. So that effect would be even bigger in a typical home setting.
Does the type of hot tool matter? Like straightener versus curler versus waver?
It seems to. They all emit particles. But straighteners and curlers tended to produce more of those really ultrafine particles, the tiny ones, peaking around 20-35 nanometers.
Okay.
Wavers tended to produce slightly larger particles, peaking around 100 nanometers. But either way, you're still looking at significant doses getting into the lungs.
And what about the products themselves? Does using a fancy serum versus a cheap one change things?
You know, interestingly, at those high temperatures, the type of product didn't seem to make a huge difference to the number of nanoparticles.
Oh, really? That's surprising.
Yeah. But the specific chemicals being released, the VOCs or volatile organic compounds, did vary depending on the product formulation. So the chemical signature changes, even if the particle count is similar at high heat.
Okay, so wrapping this up, what's the big takeaway here?
I think the main point is that this research really flags heat-based hairstyling as a potentially significant source of indoor nanoparticles.
Yeah.
It's an exposure risk, right in our homes, that we probably haven't paid much attention to before.
It changes how you might think about that morning routine.
It does. It definitely raises an important question for you, the listener. Knowing that your styling might be putting billions of nanoparticles into your lungs.
Yeah.
What simple steps could you maybe take, in your own home to perhaps reduce that exposure? Something to think about.